Hang on one second. Okay. Okay. So like I said, I am new to Lambda, so I'm still figuring that out. And also, I noticed several of you posting about the particular computer that you have, and you were saying a lot of people said they have Windows. I am an old Windows Linux user. When I started with Lambda School, they handed me a Macintosh, and so I have been adjusting over to the Mac, and so I am still getting used to that. So, but let's get started. So again, my name is John Mitchell, and we are doing the backend with Java Lambda course. This is the software right now that you will need to have installed. For today, as we mentioned in the intro to the class, you needed to have installed the JDK version 11. And there's some other things that we'll need to install as we go on. Tomorrow, specifically, we will need the IntelliJ IDE Ultimate, and that you can get from your GitHub Student Developer Pack. And that's the main IDE, Integrated Development Environment, that we are going to be using. For today, we just need the JDK version 11 and a text editor, and all of you, your operating system by default installs a text editor you can use. So how the course is going to flow. We don't have any of the pre-class videos. So typically what's supposed to happen at Lambda is we have some pre-class videos that go through some of the details of things, and then we go through a guided project during this time. I'm going to be combining both of those during this class. So just wanted to let you know there'll be a little bit of direct instruction, and then there'll be some time where we do things together. And what I'm thinking is that I have things broken up into about 20, 25 minute-ish times, which then we can have a little break between those to let our brain kind of rest and reset so that we know what we're doing. So to ask questions, so we are doing day one, so let's do let's see here. Let's do I have created out on Slack under JX a message thread that I just called Day One Questions. And if you have a question during my presentation, that is the place to post it. If for some reason I can't figure that out, I can't get to your question during classes, then I will certainly address it after class. That message thread is not going away. The other thing to keep in mind is there's nothing magical about who answers the question. So if you can answer a question that gets posted in there and it's not going to interrupt your paying attention to what's going on here, do feel free to jump in. We're all in this together. We'll all get this done together, and together we'll succeed. So that's enough of introductions. Let's get started in actually the material. So one of the first questions that comes up is, why Java? Well, of course, there's plenty of jobs out there available for Java programmers, so that's a good thing. One of the things we know about Java is arguably there's more lines of code written in Java than in any other programming language that's out there. JavaScript is actually getting pretty close, and some people say has already surpassed Java. But when you think about Java, Java's the main language for Android programming, so anything that's done in Android is done in Java. There's a lot of internet, IoT, Internet of Things devices that are programmed in Java. when you install Java, it says over 3 billion devices use it. Personally, I think that's a little low. Java is also a very popular introductory language. A lot of colleges use Java to get started. Uh, High schools will use it. If you took an advanced programming class at a U.S. high school, you probably learned Java. So Java is known by a lot of people out there. And because of that, a lot of our larger companies and some of our older companies actually use Java. So these are some great reasons why we're learning Java. Java was first released back in the mid 1990s by a place called Sun Microsystems, which became part of Oracle. Java's had some interesting numbering, and this is important. A lot of companies still are staying with version 8. Well, actually, Java version 8 is version 1.8, but we all call it version 8. Once we switched over to version 9, things radically changed, and we are now just calling them version 9. They dropped the 1 point idea. We are going to be using version 11. Version 11 is the current long-term support version that Oracle has available for Java. And so that is, if a company's, many companies now have switched over to version 11 because of Oracle's promise for long-term support. You'll see version 8 and you'll see version 11 a lot out there. So a little bit about Java. Most of you probably know that Java is not at all related to JavaScript, other than they share 4 letters. The traditional thing people say is that Java is to JavaScript like a car is to carpet. I like the lamb to lambda school. It was either named after the drink or the island where the beans come from. It doesn't really matter, but it was named after, you know, Java. You think of coffee, and that is where the name came from. This is important. So when Java first came out, they had to make a choice of how they were going to get Java to run. And what they decided to do was they kind of went a middle way. Every machine that runs Java has a Java virtual machine, a JVM that runs on it. And so what happens is you take your Java compiler and you compile down to a thing that's called bytecode. And bytecode then is the thing that actually gets implemented by the virtual machine, who then converts that bytecode to machine code that can actually run on the device. There are some of our IoT devices where you can compile directly to the device, but normally we go through this process of creating bytecode. When we're talking about Java, there's actually 3 big parts of Java that are out there. There's the JVM, that's the Java virtual machine, and that's the thing that executes the bytecode. But that's not enough to actually run Java on your machine. You also have to install the Java runtime environment. So when you install the JVM, you're actually installing 2 things. You're installing the Java runtime environment, which are all of these APIs and all these support libraries that the JVM needs to actually access and execute the bytecode. What I said we had to install was the Java Development Kit, the JDK, and that allows you to actually write code and then convert it to the bytecode. And a lot of times if people have Java installed on their machines, when they say they have Java installed, they really have the JRE and the JVM. The only time to install the JDK is if you actually wanted to do some programming, which is what we're doing. When we talk about Java, there's really 3 main areas of Java, and this is my own breakup from talking to people in the Java world. But this is what we seem to have broken Java into these three strands. There's what I would call is core Java. That's the thing that most of the people that have used Java as an intro language, that's what they're learning is core Java. And that's what we use to program the IoT devices. Then there's Android, and you have to know Java in order to program Androids. But Android is a completely different thing that's out there. And there's a reason why Lambda School has its own Android program, because it is that different from the other two branches of Java. And then what we're talking about is we're talking about web Java. How are we going to use Java to handle the back-end web servers that companies need? So we're going to do enough of the core Java to figure out how to do the web Java. We're not going to touch Android at all. We have other classes for that. But this is just kind of the way when people say they know Java, you kind of have to ask, well, which route have you gone in Java so you'll know what they're talking about. Java Development Kit, which is the thing that I told you we needed to install. Java has some really mature integrated development environments. And there's really three main ones that are out there. There's NetBeans, which is done by Sun Micro and then Oracle. The two most popular ones that are out there, though, are Eclipse. And if you've ever heard anyone talk about Java development, you have probably heard about Eclipse. Eclipse is really nice, but its main feature that people like about it is it's free. It does a good job, and it's free, so that's good. IntelliJ IDE is by far the best IDE that's available for Java, and it is really slick. There is a free version. There's a community version that you can use. We're going to be using the ultimate version in this class, but I would, if you've done any Java programming and you haven't looked at the IntelliJ IDE, you really want to, because it is a really slick program. So I want to stop right there for a second and kind of address some of the questions that we have, because our next step, we're going to actually start writing some code. So let's see. When are we going to need SQLite? We'll need SQLite for the third week, so that's kind of down the road, and I'll get you some more instructions on how to install that for your particular environment. You shouldn't have to buy the IntelliJ IDE for this course. It should come as part of your GitHub Student Developer Pack. I will say this, if for the first week, if you're having trouble getting the Ultimate installed, for the first week, the community version will be just fine. It's when we actually start getting into more of the web APIs that we're going to need the Ultimate. And I'll be showing you some ways that you can use just the community version, but the Ultimate it's actually worth the money. But for this course, you shouldn't have to buy it. It's part of your GitHub development pack. So there was a comment that I said you needed to know Java in order to program Android. There are a lot of compilers that will take other languages and convert them over to Android, but to do basic Android programming, really you need Java. Kotlin is starting to be an alternative. Personally, I would say Kotlin is just a derivative of Java. I know the Kotlin people will get upset, but that's the way I look at it. One of the questions was, and this is actually a very good point, it used to be that Java was free. No question about it. Every part of Java was free, and you could use it for whatever you wanted. really starting with their latest version 11 long-term support, it's really kicked in where it's free to do development work. And really, the bottom line with the new licensing that Oracle has gone through is if you're using it for learning, if you're using it to do your own development, even if you're using to do it development for a company, it's okay to use the free version. If your company starts making money off of their Java, then they have to pay for it. And to be quite honest, I have looked at the payment scheme and I think Oracle has it all over the board. Your best bet is to talk to your Oracle representative, sales rep, to see what you need to do. But keep in mind, pretty much everything we're going to be doing and what a lot of people are doing is still freely available. All right. What I would like to do now before we actually get started on some code is I would like to take a 5-minute break. And I'm going to see, hang on one second. I'm going to see if I can work my Macintosh to actually get a 5-minute timer. I can't, and I know what my problem is, and I will fix it during the 5 minutes. So let's come back at 9:25. That'll be actually a 4-minute break, and we will get started. So I will see you in about 4 minutes. Apparently my mic is still open. Hi. Thank you. All right, it's time to get started again. A couple of questions that came in over the break. Uh, yeah, the 5-minute timer on Google is great. Still learning around the Mac. I was having trouble finding where I could get to a browser, but I've got that worked out now. There are two different, and this is one thing I did not address, and this was a very good question. There are two different versions of Java that are out there right now. There's an Oracle version and there is an open version. I prefer the Oracle version, and most companies up till now have been using the Oracle version. However, with the complex pricing scheme that Oracle has gone through, I can see a bunch of companies switching over to the open version, which will remain free forever. So for our class, it should not make any difference. You should be able to install either one. Everything that I talk about will be the Oracle version, but they should work fine together. And of course, if you are using the open version and there's something that doesn't work, let us know, because then we'll all learn. All right, let's get started with actually doing some code. So let me share my screen. Now, the first thing that we want to do is when we're working with the Java environment, we're going to do everything today from a terminal or a command prompt. Hang on one second. That decided to do not what I wanted. All right, let's try this again. Okay, I like that better. The Mac is causing a lot more problems than I thought it would. There we go. That's what I was after. Okay. So I've gone to a terminal prompt. You can go to a command prompt, and how you get to that varies by your operating system. You should all know how to do that from previous Lambda courses. And that's one thing I want to stress here. We've all done courses through Lambda. So, and we're all programmers, maybe just not Java programmers. So when I talk about things, I'm going to assume you know some of the terminology. Like when we talk about loops, for example, I'm not going to tell you what a loop is. I'm going to show you how they're done in Java, because we're making the assumption that you already have gone through that. Well, let's get started. So this is something that you should follow along with. Your hand should be on the keyboard. And to the person that posted in the forum that Linux is easier, I agree. I'm a big Linux fan. All right, let's get started. So the first thing that we need to do is we need to create a directory where we're going to keep all of our stuff. So I'm going to make a directory that I'm just going to call projects. I just happen to have, I don't have one called projects yet, so I'm going to make one that's called projects. And then I'm going to change directories to that project file. Now, the JDK is very picky about how the directory structure lays out. So here's what I'm going to do. I'm going to create a folder, a directory. By the way, for those of you that don't know, the words folder and directory, I will end up using interchangeably. I've been around long enough that they were directories when I started learning, and I've been trying to adapt to the word folder. So just translate. If you hear me say directory or folder, it's the same thing. So I'm going to create a folder that I'm going to call employee app. And we're going to create a little small application in Java that works with employee data and things. So that's why I'm creating this directory. And now I'm going to change to that directory. And I'm going to create another directory that's called source. And this is very important. You have to have a directory that's called source when you're working with Java. And then under the source directory, we need to create the directory for the project that we're going to be creating, or the package, as we call them in Java. So let's create the package that we're going to want. And the package that we want is I'm going to call it employee app. Java is case sensitive. So so everything that we do, the case matters. So just keep that in mind as we go forward. All right. Now, let's create our first text file. Now, you can create this text file any way you want. So I don't care what text editor you use, as long as it creates a basic text file. I'm going to use Nano. Nano is a text editor that's available for the Macintosh. It's available for Linux. I've used it a lot under Linux. If you've installed the Get Bash on your Windows machine, which if you haven't, I highly recommend you do that. You can use Nano on a Windows machine. Notepad works great. So Nano, sorry, I need to change to my folder. So now I'm under my package folder, and I'm going to create my first file, which I'm going to call employee.java. The file name in Java, the file name of we're going to create a class in here. And in Java, the file name and your class name have to match. In Java, when we create a class, the class name is always capitalized. It doesn't have to be. There's no rule that says it has to be, except that is the standard. And if you don't do it, people are going to look at you and say you're not a Java programmer. So you have to capitalize your classes. The other thing that's important to keep in mind is, unlike other languages you might have worked with, Java has two characteristics that are incredibly important. One is it's object-oriented based, and it has been object-oriented based from the founding. That was one of the guiding principles when they created Java. As such, everything that happens in Java is a class, and then we instantiate objects from it. You can get by, like in JavaScript, you can get by without having classes, and they have these things called prototypes that kind of work as classes. I'm not a real big JavaScript programmer, but I know a little bit about it. And that's not the case in Java. Java, you have to have a class of some sort to run anything. And second, Java is a strongly typed language, and we're going to talk more about what that means as we actually enter some code. So let's enter some code. Now, I'm just in a flat text editor. This Nano does absolutely nothing for me. If If I'm looking at some paper, it's because I have my code printed out. Let's get started with some things. The first thing we're going to need is we have to know what package this is part of. And if you remember, we created a folder to put all this stuff in that we called employee app, that case. And we have to call our package the same thing. Now, I said we also needed to call the class the same name as we saved our file. So we called our file employee, our class also has to be called employee. Curly brackets are braces. The Java world is still kind of in flux as to which ones, where they decide to put them. A lot of people still put them at the end of the file like that, and that is really getting to be popular, mainly because JavaScript really kind of got this started. The old-timey guys in Java like to put it down there. It doesn't matter is the bottom line, but you're going to see me put it on this line. The people that do IoT programming, the people that do core Java, and a lot of your people that have been doing web Java for a long time put that opening brace on a new line. So that's where I'm going to do it. All right. Now, let's go in through here, and we're just going to create some things. With employee, in Java, you have to tell it up front. If you want a variable and you want to use it for something, you have to tell it up front what it's going to be. So I'm just going to start this. Private. Private is a keyword in Java that tells it that only this class, so only employee, is going to know about this particular variable. Static, we'll come back to what it means, but it actually means it's a class variable, and we'll come back to what that means in a little bit. We are going to create this as an integer. In Java, when you create a variable, you have to tell it up front what that type is going to be. And you have to tell it up front, it's going to be an integer, it's going to be a string, it's going to be a Boolean, it's going to be a double, and it's going to stay that way for the rest of the program's life. So, you know, in a lot of languages, you can say, oh, I want some memory location to store something out there, and the compiler says, oh, cool. Java says, no, stop. What are you going to put in it? I need to know now. So we have to tell it up front what it's going to be, and that's really what we mean by a strongly typed language. So I'm going to call this variable max ID, and I'm going to initialize it with a value of 0. Okay, let's keep going. We're just going to create some more variables here, and the point of this is I'm going to show you how to create a class, and we're also going to talk about how some of the data types, some of the base data types in Java work. So let's create another field. It's private. Only employee is going to know about it. And I'm going to call this one ID. Now, it's an int. It's going to be an integer. Int is one of the basic types in Java. And notice I did not use the word static. The difference between static and not static. Static is what we call a class level field in this case. And that means all classes, all objects that get instantiated from this class, that get created from this class, are going to share the same value of max ID. So max ID is going to be the same across all objects of employees. An object field, which does not have the word static, is individual for each object. So that's kind of like what we're used to, is that each object has its own ID. But in our case, static means that that value is going to be shared across all of the objects. So all the objects will have the exact same max ID, but they'll all have different IDs. Let's do another private string first name. Now, in Java, strings is a class. It's actually a built-in class in Java. And so because it's a class, it is capitalized. Because again, as we mentioned, we always capitalize our classes. All right, that's first name. And yes, most of the time when we're working in Java, our object fields and our class fields are private, and then we use getter and setter methods to access them. We'll get that. All right, so we have a first name. Let's do a last name. Then I have just some other fields that I'm going to throw in here so we can look at some things. One is it's going to have a double. In Java, we have double, which is a real number. So an integer, remember, cannot have any decimal parts. A double, which is a real number, has to have a decimal part. And we'll talk more about that as we go on. We also have floats. We try not to use floats in Java, although sometimes we have to because of backwards compatibility, and it was actually put in for backwards compatibility. And then a couple of other fields that we need. We need a company ID. Sorry, we need a company ID. Fields should be lowercase. And we're also going to have a health plan ID. Okay. By the way, of what we're doing in this guided project, this is the longest class we have. That's the one we're doing first. All right, let's take a look at, so when we have an object, we have a class, and we're ready to instantiate an object. We're ready to make an object of that class. In order to do that, in order to construct that object, we have, it calls something called a constructor. If we have a constructor, great, it'll calls it and use it. If we don't put a constructor in, there's a default constructor that will run. But we want a constructor. So what's a constructor? Well, a constructor has to be public because people outside of the class have to be able to use it. It does not have a type. It's the only method that we're going to put inside our class that doesn't have a type. And it has to be the same name as the class. All right. When we create this class, we need to send it some values to help create it. For instance, we need to know what the first name of the employee is. We need to know what the last name of the employee is. So there's some things we need to know about the employee when we create the employee class. And so that's what goes in this parameter list. And one of the things, we need to know their first name. We need to know their last name. We need to know their salary. And now notice in doing this, I am giving it the type that we need because again, Java is going to demand to know what the type is. So I'm giving it the type. And then I'm giving it a name. The name doesn't, it can be anything as long as it makes sense in the context of what we're doing. But if I wanted to call these X, Y, Z, dog, cat, I could, but they wouldn't make sense in the context. So that's, but it doesn't, the names are irrelevant to the Java compiler. Okay. All right, so now that we have the constructor, what we need to do is, one of the interesting things about Java is that when this constructor ends, the list of things that we have in our parameter list, that's the thing between the parentheses, those are all going to go away. Those values all go away. So we need to somehow stuff those values into the memory location that the class, the object, knows about. So let's do that. This refers to the object. So the object's first name, we want it to equal the parameter first name. All right, let's do the next one. This last name, we want it to equal the parameter last name. This salary, we want to equal salary from the parameter list. This company ID, we want to equal the parameter company ID. This health plan ID, whoops, that's not right. That's better, equals health plan ID. I did have a typo up here in my parameter list, so I need to come up here and change that. Now, there is one field that we're missing, and that is ID. Well, when I create an employee, I'm not going to send it its ID. I'm going to have the class automatically calculate an ID for me. So the first ID, the first employee will have an ID of 1, the second employee will have an ID of 2, and that sort of thing. Now, we're going to keep track of the maximum ID. So what is the maximum ID that's been assigned to an employee? We're going to keep track of that in the max ID variable. So we can do the adding this way. R, that's just a shortcut. By the way, that is how you do a comment in Java. That is a shortcut for max ID equals max ID plus 1. Now, we need to make sure that the current ID, though, equals that max ID, so we have to do an ID equals max ID. All right. I'm going to pause there for a second, and I'm going to take a look at the message thread. I've been kind of watching it, but I don't think y'all have been doing a great job of answering people's questions. The one I did want to point out was this is not going to be a static class. This is actually going to be a class that we instantiate. So we do want to, this is correct. We have a static field inside of our class, and that's okay. But this is actually going to be, this is not going to be a static class. All right, let's keep going. So I mentioned that these things were private, that the ID was private, the first name is private, the last name is private. Only this class are the objects that get instantiated from that. Those are the only ones that know about these fields. Well, somehow the outside world is going to have to cooperate, or it's going to have to access these, or it's not very useful. The way we do that is through something called getters and setters. Getters allow us to read the information from the object, and setters allow us to set the information in the object. So one of the things is we want to be able to get the ID. So we want to be able to find out what the employee ID is. For getters, the typical thing is you use the word get and then the name of the field. So it's get ID. Notice that we're using the camel case in here, where the first word is lowercase, the second word is uppercase, and it keeps going like that. So all this needs to do now, notice that this particular method is public, so anyone can access it. It's of type int, meaning that it has to return an integer value. So before this method finishes executing, it has to somehow return an integer value. In our case, all we needed to do is do a return ID. All right. Let's do the same thing. This time, let's do something a little bit different. With name, with first name and last name, yes, we might want to get the employee's first name or last name, but we might want to get just their name. So let's create a method that's going to just return the employee's name. Now, notice that even though there are no parameters, I still have to have these parentheses around it. The parentheses are the things that say, yes, this is a method. So here we want to return, and we want to return the first name. And then, and you can concatenate strings this way in Java with the plus symbol. So we want to return the first name, a space, and then the last name. And that returns name for us. Well, what if we wanted to just individually, what if we wanted or needed to change their name? So the employee decides to change his name and we need to have some way to do that. Well, at this point, there's no way to do that after the employee gets created. Well, let's put in a setter to set his first name. Okay, so here's what we have. We have a public so that everyone can access it. We have the type it's going to return. In our case, it's going to return a void, meaning there is no return type. But you have to specifically tell Java there's no return type. And we want to set the first name. Now, the parameter that's going to come in with this method is going to be called first name. So let's do this. This is very similar to what we did in the constructor, but this way people can call it even after the object has been created. All right, let's do a similar type thing with last name. Set last name. So it's the same idea, except what if they just changed their last name? You know, the first one we worked on the first name, well, now we're working on the last name. All right. Let's run through. Let's do the rest of these getters and setters. Well, we had salary. So let's do a getter for salary. And it was public at salary. and we just want to return salary. And then let's do a setter for this. And again, it's public. It's void because it's not going to return a value, but we have to specifically go ahead and tell it that. And it's going to take a parameter that's a double, and it's going to set salary to be salary. I'm going to add one, well, we'll come back to that. Let's do this. Let's create one more class. I do, thank you for pointing that out. This is supposed to be double. And in a few minutes, we're going to compile this, and it will find all these nice little typos that I've done. But let's create one more class here real quick. Let's take a look at, so I'm going to exit out of this. I am done with this class for right now. So I'm going to exit out, and I'm going to move on to a new class. So in other words, I need to save this file, and I need to create a new file. And this time, I'm going to create something for health plan. So health plan is going to be the class name. So I'm going to have to call the file name that. And it is a class, so it is capitalized. And now it's going to be very similar to what we just did. Let's create a package. And it's the same package, and it's this package name is how all the different objects in one group, all the different classes in one application know about each other because they're all in the same package. And it's a public class, and we decided to call it health plan. And let's see, we're going to do the same concept that we did with employee for an ID. And so let's do that. So we need to have this idea of a maximum ID. We need to have the idea of a local ID. So we have a static maximum ID that's going to be the same value throughout all the objects. We have an ID that's going to be specific to this object. And for health plan, we are just going to have a name. And it's going to be a string. And remember, the string data type is a class, so it has to be capitalized. All right, let's create a constructor. So just like we did before, constructor is public. It doesn't have a type. It has to be the same name as the class. And this constructor is going to take a single parameter, which is called name. Now, I kind of jumped over this before, and I want to stress this right here. So I'm saying this dot name is name. This dot name refers to the name that is part of the object. So that's name. This name right here refers to the parameter name right there. And this is the common way people do it. Let me show you something else that might help here. Now, the reason that we have to use the word this is that this name and this name are the same variable name. Java would just be very happy to go on and use this name all along. So if we did something like this, if we did that, what that would do is this particular variable, this particular memory location, would take its value and put it into itself. The constructor would end and everything would go away. We wouldn't have any idea what the name is because we didn't save it anywhere in the object. To save it in the object, we have to use the this keyword. All right, let's see, what do we want to do here? Well, let's be able to return. So we have a getter that's going to get the ID. And in this case, to save us some typing, we're not going to be able to change the name. We're just going to do get name. So that's all we want for this class. Let's do this. I'm going to leave this up, but let's take a 5-minute break and let's come back in 5 minutes. And in this time, let's see. Would you stop? You stop, meaning I'm talking to Safari here. So let me go to Google. And do a 5-minute timer. All right, this is what I wanted to do before. It's counting. Take a break. Okay, let's get started back on this. Now, it was pointed out by a few of you, and I appreciate this, that I did leave out something here. So that was good. So in this, you get out of the way. Thank you. Um, in this constructor right here in health plan, I didn't do anything with the max ID and the ID. So we never get assigned an ID. So you're right. This get ID method would always return, well, whatever the default value of an integer is, which currently in Java, they're setting it to be 0. Sometimes they had it where they set it to be whatever. So we don't know what it would be, in other words. So let's fix that. So I am still in my editor, so I can come up here and we're going to do max ID. Just like we did before, we're going to add 1 to it. And then we're going to set ID equals max ID. And notice in this case, we don't need the word this because there's only one ID that's known in the constructor, and that happens to be the one for the object. Okay, I think we're in good shape with that one. Let's create one more class, and then we're going to get to the point where we can actually use the class and do something with it. So let's create one more class though. So I'm going to go on and exit out of this. And by the way, for those of you that said it must be really tough to use Nano, it is for this. Tomorrow, when we get into the IDE, you'll wonder why we ever used this at all. But you really, in order to be a Java programmer, you're going to have to know your way around the JDK. And so that's the point of why we're doing it this way. Let's create a company class. So nano company.java. Company has to be capitalized. It is part of the same package, so just like we've been doing. And it's the same process over and over again. So public class company. And we're going to want to have a ID, just like we're going to do the same ID process that we did before. So we have our class. If I can spell. Okay, there we go. Good. We have our class variable that we created, a class field, and then we need to have the one for the object as well. Now, in this case, I'm not going to use getters and setters. And the reason I'm not going to use getters and setters is, one, to save on some typing, but two, just to show you there is another way out there. So public, that means anyone can access it. ID. So public int ID. Anyone's going to be able to access it. It has to be an integer, and we're calling it ID. Let's create a name for this guy. That's a string. Let's create a integer field that I'm going to call debt, and mainly I'm creating this because I want to show you some things you can do with integers, but in case the company has some debt, we're going to include that right here. And I also want to include one other thing. I want to include a constant that's going to stay the same throughout all objects. It happens to be a double. And this is what they're going to use for their 401k matching retirement plans. and all companies are going to use the same number. Because that's what I just said here. It's final, meaning that no one can change it. It's static, meaning it's going to be shared. The same number is going to be shared across all the objects, so across all the companies. And then it's a double, and we gave it a name. So that's a way to do a constant that is part of a class. Let's create a constructor for this. So public company, the name of the class. It's going to take in two parameters. There's going to be the name of the company, and there's going to be the debt that the company has. Now, I'm going to put this dot ID equals max ID. Okay, so what I did here, this keyword I can throw in here if I want to. It's not wrong. It's just not needed because there's only one ID variable inside of company. So we know which one we're referring to. So we really don't need the this. The other thing is you can increment the variable, the field max ID. You can increment that during the operation, which you can do this a lot in other languages as well. That's great. In Java, we try not to do those things. I know in some languages, combining operations is actually a popular thing. In the Java world, we generally try to leave those things separate. So I'm going to pull that out, but I wanted to show you that is possible. You will see that, but it's not necessarily the best programming style for the Java world. All right, we also then need to make sure that name is captured in the field and that debt is also captured in the field. Now, because we made everything public, we don't have to have any getters and setters. The getters and setters is the preferred method, but you will see this a lot, so I wanted to at least show you an example of this. So we don't need to create any getters and setters because we're good. All right, let's exit out of this. All right, we've got one last class we need to create. So let's create this last class. And this one is going to be main. And in Java, we have to tell it which class we're going to start with. And in our case, we're going to start with a class that's called main. We could call it anything we want. By standard, you call it main. Okay, so let's do this. So here we have the main class. It is still part of our package, just like all the others were. It is, we have to have public class main, just like we did before. And now then, we're going to create our main method that's going to run. It's going to be public so that anyone could run it. It will be static. This main class is going to be a static class, and that's the only time that the only thing we'll be able to do is use this as a class. We cannot instantiate this as an object. The arguments that come into main, let's going to be an array, and we'll talk a whole lot more about arrays tomorrow, but it's going to be an array of arguments. We're not going to actually send it any arguments, but just in case, we do have to have that in there. And all this is going to do is this is going to run another method. So all this method right here is going to do is it's going to run another method that I'm going to call work with data. That's great, but now we need to write so we're done with this, except we probably need to write with what the work with data means. I don't think Java knows what that means until we tell it. So let's come up here and let's create a private class. A private method that's called work with data. It is static. It's only going to be run inside of this class. It's not going to return any values, and we called it work with data. All right. Now let's actually start using some of the work that we just did. So we created a class called health plan. Now we want to do something with health plan. Having the class is nice, but we actually want to do something with it. So let's do that. Let's instantiate a health plan that we're going to call H1. So it's of type, H1 is of type health plan. And we're going to create a new health plan object. And if you recall, when we create a health plan, we have to give it a name. Now in our IDE, it would have prompted us for that, but right now we just have to know that we want that. You can call it anything you want, but My Health 1 works well. So to instantiate an object so we can actually do something with it, we have to have the type. So that's the class. This is the object name. We are creating a new one of these guys. And one of these guys that we're creating is called health plan. Yes, we have health plan listed twice in this expression. It's listed here as the data type. And then it's also listed here as the thing we're creating. And then we fire off the constructor. We call the constructor, and the constructor requires a parameter that is the health plan name. You'll see this a lot. We do this a lot. Let's create another one. Here, I'm going to be real original with my naming, and I'm going to call this one My Health 2. So we now have two health plans that are out there. All right. Let's create a company. Why not? Let's create a company. So it's the same idea, company. I'm going to call it C1. It's going to be a company, like we just said. Companies get names, and companies also have to have debt. Now, a couple of things about this. Notice that when we created the company class, when we listed the parameters in the company class, we had them in order. So name came first and then debt. So we have to follow that same order when we're instantiating the object. And while we're here, let's do another one. Let's do C2. And again, I will be very creative, and I will call this one Company B. And we're going to have Company B have $100 in debt. Okay. So we have health plans, we have companies. Seems like the next thing we would need would be employees. So let's create employees. We do it the same way. All right, now with employees, this becomes interesting. We have the first name. We have the last name. We have the salary. Then we need to send it the company ID and the health plan ID. When we set up company, we made the ID a public field. So to access it, we just have to use the object name dot its parameter or its field. So the object name and its field. That's all we have to do. Now, with the health plan, we set it up with the getter and setter idea. So we have to call a method in order to get the ID, which is H1 get ID. We know it's a method because it has the two parentheses after it. In Java, you have to put the parentheses after a method, otherwise it's not a method. Let's create another one. Let's create another employee, very similar. Employee emp2 equals new employee, so it's the same idea. If you're using a GUI-based text editor, yes, copy and paste works great here. It works for Nano, but it's clunky. I'd rather just retype it. And I'm going to call this person May Ford, and this person's going to be making 80,000. And they are going to still work for company one, and they are going to be on the second health plan. We know they're on the second health plan because instead of getting the information, the ID from the H1 healthcare object, we got it from the H2 healthcare object. And let's just create one more employee for now. Doug Jones. Doug Jones is going to be making 75,000, and he's going to work for company 2, and he is going to be on healthcare 2. Okay, so now we've got some data that we can work with, and we can do some things. So what I'm going to do next, the next series of commands that I'm going to do is just to show you some things in Java and how some things work. So let's start with how do we display something to the screen? How do we display something to the console? Well, it's part of the system library class, out, print line, and then it takes a parameter of whatever you want to print out. In this case, I'm going to just say we're query data. Okay. And the one thing I want to print out right now, the only thing I want to print out right now is C1. So that's the object C1. Every object that you instantiate as a default what's called toString method that gets created. And you could do this, and that would call this toString method that is going to print out some information about the object. But you can also do this way in Java, and it knows to print the toString. So I'm going to leave it like that. Now, we are ready to actually execute this project. Well, let's do that. All right, so I'm going to have to exit out. And now we need to be at a command prompt, at a terminal prompt. If I do, this is on a Mac, but this also works on Linux. If I do a print working directory, you can see that's where I am in my directory flow. Let's move up a folder. All right, so this is the name of our application. This is the source code that we're working with. And then this is one of our packages that we have in this application. So I want to be on where we're just looking at the source code. So if I do an ls or a dir, if I do an ls, that'll show me the packages that I have. And I have one package that's called employee app. The first thing we need to do, and this is the thing that's going to catch all of your syntax errors, so we're going to have to make some edits after we run this. The first thing we want to do is we want to take the code that we just typed in and compile it, translate it to that byte code. So here's what we do. We give it the name of the project, of the package, and the files that we're compiling this. Let's use the Java compiler. Java C, and this is something that got installed when you did the Java JDK. And if you just do a Java C-version, it will come up and tell you, I happen to have version 11.01 installed. A lot of you are going to have 11.02. That's fine. As long as it's 11 something, we're in good shape. Let's compile this now. Java C, the name of the package, and then we want to compile all of the Java files that are in the package. And you'll notice that when I ran this, I got some errors. And I'm going to have to go back and take a look to see what I did. But this is where we are now going to go back and fix some things. So I can take a look at this right now. If I looked at this first one, when I created this object, I forgot to put my comma between these two parameters. So I'm going to go in and edit that, and I think that's going to fix most of my problems. So to fix that, I have to get back into the file. It happens to have come from main.java, and it is on line 15-ish where the problem is. Now, remember that this is in our package, so we're going to have to edit the file from our package. And in, we had forgotten this comma right here. All right, let's exit out. Let's try doing this again. Let's try compiling it again. Now, since I'm in this Mac environment, I can just tab arrow key up, found the line that I want, and notice I get nothing back. That means everything worked. So let's now, what we have to do next. So this gives us, let's just do this. So notice we had created the Java files. We now have these things called .class files. The .class is where the bytecode resides. And so those are the things, if you wanted to ship these things around, those are the things that you could ship around, but that's not normally what we do. Normally, we combine them all into a jar file. And if you've ever run anything in Java, you've probably executed the jar file. Well, here's how you create one. All right. Well, we do jar. We want to create a new archive file. That's the jar file. We want to generate the verbose output of this. We're going to specify what the name of our file is going to be, and we're going to make sure that we set the point of entry, what the first thing is we want to run. So in other words, we do jar space those options. And I'm going to call this imp app jar. Doesn't really matter. You could call it anything you want, but that's the name of my jar file. And I'm going to, when I start this thing, I want it to start in the package employee app .main. That's the class that I want it to start in. And what I want to include in this is all of the class files from our project. And it goes through now and it adds all of those class files into your project. Okay. Now we're ready to actually execute it and see what we can do. Now, you could run the class files by themselves and not convert it to a jar file if you only had one object you were working with. I don't like doing that. I always convert mine to a jar file. So now we just run Java, which Java is something that gets installed even when you install just the Java runtime environment. So everyone that has Java has this installed at least. It is a jar file, and the name of it is imp.app, and it's a jar file. And you'll notice it goes out and it prints something. So what it did was it printed that query data that we put in the print line, and it also printed out something related to the company. That happens to be the name of the object. That's not really very useful. Let's go see if we can fix that. All right. Let me find. All right. Let's go fix that. Let's get into company. So we're going to go edit. So I want to edit. So we're going to make a change so that when we print out company right here, this is going to print out something that's a little more useful to us. So it's under the package. It is company.java. And what I want to do is I want to change the default to string method. So I'm going to change the default to string method. And the way to do that is I want to override it. So I need to use the command override. And it has to be public. It has to return a string. The name of it is toString. And I'm going to create a return string. And what I want it to do for a company is I want it to return the ID. So I'm going to give it a label that says ID. I want it to return the ID. And then on a new line, I need to have a new line in here. And there's a lot of different ways you can do new lines. Here's one of them, is you can add the new line character, and that's going to force it to print on a new line. Now I also want to return the name. So I'm going to do the exact same thing, but this time I'm going to use the name. Now notice that ID is an integer, but I can concatenate it with a string. And what happens is integers have a toString, just like everything else. And so it's going to become a string and get it added in as a string. And then I also want to print out its debt. And even after I print out debt, I want to make sure that it gets a new line. Now, somewhere in here, this has to return this value. So let's do that. Now let's see if this helps at all. Let's see what happened here. All right, so notice, remember the first time we returned this. Now we have to go through all of those steps again in order to execute this change. So the first thing we have to do is we have to recompile everything. So that's javac, the name of the package, and we're recompiling the Java files. That also will check our syntax. Now we need to convert to the jar file. So again, it's jar, CVFE, whatever we want to call it. We are starting with the employee app.name. And we are using the classes from the package employee app. And then we need to actually execute the Java jar file. And notice this time we actually get something that's a little more readable. So the last time we got the name of the object, which was just, it was interesting but not helpful. This time we actually figure out probably what we wanted, which was the ID, the company name, and the debt they have, the information that was actually in the object. And that's probably what you normally want. Quite often we will override the toString method to do something. All right, I just want to kind of go through and show you a few things, a few little interesting things about Java and how they work. So let's get back into the main class. I'm going to go in and I'm going to edit the main class again. So again, it's the method / the name of the class. So we said that Java is a strongly typed language. So I just want to go through and show you a little bit of the side effects of that using this debt field that we created. So let's do this. let's print out. Let's just take the original debt and divide it by 5. Original divided by 5. And to do that, then, we want to take C1 debt, and we're going to divide it by 5. And both of them were 100, so divided by 5 should come out evenly. But let's take a look at something else. Let's also then do the same thing, but this time, let's divide it by 7. Okay. So what I want to do is I want to go on and I want to execute this, and I want to show you what comes out. So I'm just going to quickly execute this. We're going to compile it. We're going to create the jar, and I'm going to run it. And notice that when we take the debt and we divide it by 5, we get 20, which is great. When we take the debt and we divide it by 7, it's just doing integer arithmetic. It's only going to return the integer part because both of the things were integers. Both of our operands were integers. If we had wanted it to return the 14 point blah, 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 we would have had to somewhere put in there that one of them had to be a double. And I'm going to go back and show you there's a couple of different ways we can do that. So I'm going to go back and edit main again. So nano employee app main.java. And so if we wanted this to be the full double amount to come out, we could do a couple of things. The most normal one to do in this case would be to divide by 7.0. 7.0, I know you mathematicians will say 7 and 7.0 are the same number. That's great. They're not. In Java, they are two different numbers. 7 is an integer. 7.0 is a double. And so when you divide an integer by a double, you get a double outcome. When you divide an integer by an integer, you get an integer outcome. Now, we could have also done something else that's kind of interesting. I probably will want my quote there eventually. We could do something that's called typecasting. And what that means is we can take a number and convert it, typecast it to a different type. And you have to do that because of the strongly typed idea of Java. So one of the things we could have done, instead of dividing by the 7.0, is we could have typecast the debt. Typecast, we put the words double in front of it. That makes C1 debt a double. So either these two will give you the same result. There's just two different ways to do it. For numbers, in an example like this, probably adding the .0 to the 7 makes more sense. But there is such things as typecasting, and I just wanted to show you that that existed. let me pull up something here. Maybe. What are you doing? Why aren't you doing what I want you to do? All right. We've been talking about quite a bit about these primitive types. So in Java, we have the integer that we've already talked about. We have the double that we talked about. They have these other types that you have. We mentioned a string. Remember, a string is a class because it had the capital S, so it is not considered a primitive data type. There is a float that we try not to use if possible because the double is actually a more accurate field, although notice that the double does take up more space. Float is really in here just so we can have some backwards compatibility. Boolean, true, false, we use a lot, and the character we'll end up using a lot as well. That's a single character like an A, or it could be the Unicode characters numbers. So Java has the same basic ideas that other languages have, where we have the incremental operators. So A++, A minus minus, you can do it before as well. You can do the A works well. That's the same as doing A plus B. You'll see me do this a lot right here. You'll see me do this a lot right here. They're both correct. And there's really, it comes down to personal preference. So that's kind of a very high level, rushed introduction to Java. So where do we go from here? Well, couple of things that I've noticed walking through here is, first of all, I do need to make sure that you get a copy of this presentation, and I need to get you a copy of my code that I just worked with. I think both of those would be important things to have. The next thing that I want to show you, and I'm just going to spend a couple of minutes, we have about 10 minutes left, and I'm just going to spend a couple of minutes talking about, so what do you do next? Well, the next thing is we're going to work on something, and I will post this to the JX channel as soon as we finish this, but we're going to work on something that's called the snack bar project. And anyone that's done anything in Java, the snack bar project, a variation of it has been around since they first introduced Java. So it's something that if you've done Java, you should have to do this. So we're going to basically do the same thing that we just did, whereas we're going to create some classes, we're going to instantiate some objects, and then we're going to run through and have it do some things. So that's going to be our project for the rest of the time. So we did not take as many breaks as I had originally planned. So what I think we can do at this point is we can, I'm going to check messages and questions. Yes, the reason for it being called double is that it was double the size of a float. The float was an old C++ concept that when they switched to Java, they wanted to keep some compatibility with languages that people know. but they also wanted to be able to expand and improve the language. So that's where the double came in, but they kept the float around. So I will make sure to go ahead and post this code out somewhere where y'all can look at it. So that way you can have access to it to fix some problems, because that is something that people were talking about. And that's about what I have. So I'm going to go on and conclude for today. We'll all get back around noon, and we'll start on the snack bar project. So thank you, and keep checking the channel. We'll be posting some stuff out there.